Hi everyone, welcome back. In this video, we're going to learn everything you need to know about exponents and powers. This is a comprehensive lesson that covers all the key exponent rules you'll need for 8th grade math. Let's go ahead and review our I can statements. By the end of this video, you'll learn how to write repeated multiplication as an exponent, multiply and divide powers with the same base, raise monomials to powers, simplify zero and negative exponents, and multiply and divide monomials and simplify powers of powers. Let's get started. All right, everyone, before we start learning about exponents, let's play with a little pattern and see if you can spot what's going on. Here's a pattern: 2, 4, 8, 16, 32. What do you notice about this pattern? And what do you think is happening each time? Right. If you answered each number is doubling, we're multiplying by 2 over and over again, you will be right. So if you start with 2 and multiply 2 times 2, right, that will equal 4. And then if we multiply 2 times 2 times 2, that will equal 8. 2 times 2 times 2 times 2, it will equal 16. And then 2 times 2 times 2 times 2 times 2 will equal 32. And we can go on like this. And this is our pattern. It's doubling each time. Wow, that's a lot of 2's. Imagine if you have to go and do this 10 times. That will be a lot of 2's. So the next question I would ask, what if we want a faster way to write this? The exponential growth, right? The numbers are doubling. What if we write it in a faster way? So instead of writing, let's say 2 times 2, we can simply write 2 raised to the second power, and 2 times 2 times 2, there's 3 2's, so we can write raised to the third power, and then the next will be raised to the fourth power, and then the next will be raised to the fifth power. And the first one will be 2 raised to the first power because there's only 1 2. Okay, so as you can see, this makes it so much easier and it's so much shorter to write it this way, right? But let's try and understand what each component is in here, each part of this. So let's say if we're saying 2 raised to the fifth power, we're simply saying that 2, our base, is the number that's being multiplied, and then the 5 is our exponent. That tells us how many times that number is being multiplied, as you can see from the example here, right? 1, 2, 3, 4, 5. All right, so pretty cool, right? So now we can write big repeated multiplication in one short, powerful way. That's what exponents are all about, and that's what we're learning today. All right, let's jump in and look at some examples. Here's our first example, and power and exponents. The rule, again, we know that power of exponents is showing repeated multiplication can be written with an exponent, where base is telling us the number that's being multiplied and the exponent is telling us how many times that number is being multiplied. So let's work with our first example. Example 1, 3 raised to the fourth power. It's telling us that this is, when we expand it, will be 3 times 3 times 3 times 3. So 4 times. And then second one will be 5 raised to the second power. just tell us 5 times 5. And then the third example is telling us 10 raised to the third power means 10 times 10 times 10. Let's go ahead and write what are our bases here. So the base for the example 1 is 3, and then the exponent is 4. Second one, the base, the number that's being multiplied is 5, and the exponent that shows us how many times it's being multiplied is 2. And the third, the base is, I'm going to let you guess this one, 10, you're right, and exponent is 3. Okay, now that we understand this, let's do the opposite. I'm going to write a number here as an example for you to do on your own. So we have 6 times 6 times 6 times 6. You would write this shorter with an exponent, and 7 raised to the 5th power, you would expand this one. Go ahead and pause the video and try on your own, and then join me back. Okay, so if you've written 6 raised to the 4th power, you will be correct because 6 is multiplied by itself 4 times. 1, 2, 3, 4. Then we can expand the 7 to the 5th power to show that 7 times 7 times 7 times 7 times 7. So 1, 2, 3, 4, 5 sevens in there, and that's what it's showing us. Multiply and divide powers with the same base. That is very important. We have algebraic expressions in here, x, which means a number that is unknown, and numbers. Let's go ahead and start with multiplication rule. The rule is when you multiply exponents with the same base, that means you have to add the exponent. When you're dividing, you subtract the exponents. Well, what does this mean? The first example is x raised to the 3rd power times x raised to the 4th power. So why are we adding? So the rule is saying that we have to add the exponents. So this means that we add 3 plus 4. So that will equal x raised to the 7th power. Well, let's check our work. Are there 7 x's that are multiplied by itself? So let's go ahead and first expand this one. X raised to the 3rd power means x times x times x. And let's go ahead and do the second one, which will be x raised to the 4th power. So multiplied, that means we're multiplying the x 4 times. And if we count, we can clearly see there are 7 x's multiplied. So 1, 2, 3, 4, 5, 6, 7. All right, this is the reason we're adding the exponents to show how many x's are multiplied. So let's go ahead and do one example on your own. So I'm going to write your example. So let's go ahead and say a raised to the 2nd power times a raised to the 6th power. What would that equal? Pause the video and try it on your own. Okay, welcome back. Let's see if you got it right. So our rule says that we have to add the exponents. Let's go. A raised to the 2nd power plus 6. And that should equal a raised to the 8th power. Hopefully you got a raised to the 8th power. You can also check your work. Let's now dive into dividing numbers with exponents. The rule is subtract the exponents. So let's try and understand what that means. Okay, I'm going to erase this. Example 2. 5 raised to the 6th power divide 5 raised to the 2nd power. So in your book, it might be written like this, like a fraction, which is okay. Both ways, I'm going to show you what to do. For this particular one, so we already know that fractions means division. So it says that subtract the exponent. So that means I have 6 minus 2. And that should equal 5 raised to the 4th power. We're going to try and understand why are we subtracting. So let's go ahead and do that here. Same thing. So 5 raised to the 6th power minus 2. And this will equal 5 raised to the 4th power. Okay. Right, so let's expand so we can see if we're doing it right. So there's 6 5s at the top and 2 5s in the bottom. And so if you divide 5 by 5, it will equal 1. 5 divided by 5, it will equal 1. Then we're left with 4 5s. And then we can rewrite that as 5 raised to the 4th power. Let's work on our third example. Y raised to the 8th power times y raised to the 2nd power divided by y raised to the 5th power. This seems a little bit more complex, but again, we're going to use our knowledge about the exponent rules. So multiplication means that we're adding the exponents. Then for division, we're going to subtract the exponents. Of course, we're going to follow the order of operation rule and start from left to right. First, it's multiplication, which will be adding the exponents. 8 plus 2, which will equal y raised to the 10th power. Then we're going to go ahead and do the division, which will be subtraction, y raised to the 10th power minus 5, and that will equal y raised to the 5th power. Here's another way you could have done this and achieved the same goal. In math, it is very important to organize your information, so solving it is much easier. So to me, when I'm rewriting this expression, I can rewrite it like this in order to simplify. Let's go ahead and show you. So I could have written like this, and I feel like this is much easier for me to organize the information. And sometimes you will see some problems that look exactly like this. And from here I can say, okay, since I have multiplication at the top, I'm going to follow the multiplication rule, which will be adding the exponents. Notice the base stays the same. And in the bottom, I'm going to keep everything the same, obviously. And then go ahead and do the addition. So there will be y raised to the 10th power and y raised to the 5th power. And then I'm going to go ahead and use the division rule, which will be subtracting the exponents. And now there you have it. Y raised 10 minus 5 equals 5. Y raised to the 5th power. As you can see, we got the same answer, but information was organized just a little bit differently. You choose how you would want to organize your information. Let's go ahead and summarize what we learned and write the rule down. So, multiplying and dividing powers. When we're multiplying, we're adding the exponents. So let's go ahead and say multiply. And write the equation. So A raised to the n power times a raised to the n power means we're adding m plus n. That is the rule for multiplication. Let's go ahead and highlight it. And for division, when we're dividing, that means we are subtracting. And let's go ahead and write the rule. A raised to the n power divide by a raised to the n power means we're subtracting the exponents. You can also rewrite this as a fraction. And it will be the same thing. All right, so if you want another example, go ahead and work on this example, which will be m raised to the 5th power times m raised to the 6th power, and then m raised to the 7th power divided by m raised to the 3rd power. Go ahead and pause here and answer the questions and come back for the answer. And this means if you follow the multiplication rule, we're adding. That will be m raised to the 11th power. And for division rule, that means we're subtracting the exponent 7 minus 3. That will be m raised to the 4th power. All right, let's talk about powers of powers, and the rule is multiply the exponents and raise each factor to the power. Let's understand what that means. The rule says that we have to multiply the exponents, so let's write our first example. We're doing exactly the same thing, keeping the base the same and multiplying the exponents, and this will be x raised 3 times 2 is 6 to the 6th power. But let's try to understand how there's 6 x's multiplied. And so when we expand this, take that 2 raised to the 2nd power, what we're saying is there's 2x to the 3rd powers, right, multiplied. And this will be, if we go ahead and expand a bit more or follow the multiplication rule, we know that we're going to add the exponents. So when we do that, we can clearly see there's 6 x's. We can go ahead and expand even more. So 3 x's multiplied with another 3 x's. You can clearly see this will be 6 x's. There you have it. And that's very confusing for the students to remember. Just remember when something, a number or a variable is inside the parentheses, that just means that, and it's raised to a power, that means we have to multiply because that number with a power is raised with another power. Now let's go ahead and do the second example. Here's an interesting thing about second example where students get very confused. We have many factors in here, so let's go ahead and write that down. 2 times a squared, and then b inside the parentheses. All of these factors are raised to the 3rd power. Now first understand when the number doesn't have any exponent. For instance, if we're writing 2, 2 is raised to the 1st power because it's 2, right? And same thing for a. If it says a is raised to the 1st power. B is raised to the 1st power. That means it's just showing there's 1, 2, 1a, 1b. Okay? So let's go ahead and write those exponents next to it. You don't really need to write it, but for you to organize the information clearly and understand what you need to do and really separate those factors, Will be helpful to have that exponent of 1 in there just to help you organize the information. Okay, so let's go ahead and, since we have more than one factor in there, we can basically separate them. 2a raised to the second power and b to the first power means 2 times a to the second power times b to the first power. Okay, so let's go ahead and separate those and raise everything, every factor to the third power. Okay, 2 to the first. I'm just writing the first for visually understanding what that means. A to the second raised to the third power. And trust me, if you use this method, I know it's a bit tedious, but if you use it once or twice, it will become more natural for you to understand and raise the powers to powers and never get confused about that. So our rule says multiply the exponents. Okay, 2 times 3 and 1 times 3. Okay, here we have 2 raised to the third power, a raised to the sixth power, and b raised to the third power. Okay, since we have 2 raised to the third power, we have to evaluate that once. That means 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 is 8. So let's go ahead and write it. And now we do not need to write that multiplication sign in the middle. So let's go ahead and say a raised to the sixth power and b raised to the third. Let's go ahead and do one more, and I'll give you one example to do on your own. Okay, erase this. All right, third example. 3x y raised to the second power and second power. So when the y is raised to the second power, that doesn't mean that 3 is raised to the second power or x is raised to the second power. I'm talking about here, right here. Okay, this means that every single factor has to be raised to the second power. Let's rewrite this for us to organize the information just a little bit better. So 3 to the first power should be raised to the second power. X, the first power, should be raised to the second power. And y raised to the second power should be raised to the second power. So again, we know the rule, multiply the exponents. Two times 2. Rewriting it, 3 raised to the second power, x to the second power, and y to the fourth power, because 2 times 2 equals 4. Again, we're going to evaluate 3. 3 raised to the second power equals 3 times 3, which will equal 9. Okay, let's go ahead and write 9x to the second power and y to the fourth power. There you have it. Here is your answer. Are you ready for your own example? Let's get started. I'll give you 2 examples. Okay, so we have 5m raised to the second power and n raised to the third power. Example 5 is 5 raised to the second power raised to the third power, and then 6, one more extra if you want, x raised to the third power, and this will be raised to the fifth power. Go ahead and pause the video and try on your own. So here I'm going to raise everything to the third power, including 5. 5 raised to the third power will be 5 times 5, which will equal 25, and 25 times 5, which will equal 125. M raised to the second power raised to the third power. Again, I'm going to multiply the exponent, which will be 2 times 3, m to the 6th power. And n raised to the third power, it will be 1 times 3, and then n to the third power. Here's the answer for the first one. 5 raised to the second power raised to the third power will be 5 raised to the 2 times 3 is 6. I'm not going to evaluate that. And then x raised to the third power, and then that raised to the 5th power will be x to the 15th power. Again, we're multiplying the exponents. Let's go ahead and write our rule as a summary. Okay, the rule is multiply the exponents and raise each factor to the power, and this will mean a and b raised to the nth power means that a is raised to the nth power, and then b is raised to the nth power as well. Here's something for you to remember, as well as a raised to the n power, and this is raised to the n power, means you have to multiply n times m. There you have it. So again, one of the biggest errors that my students do is do not raise each factor to the power that they see outside of the parentheses, and so make sure you are doing that when you have multi-factors in your expression. This might be very confusing for some students, but once I explain it, it will be easy. Anything that is raised to the 0 power equals 1, as long as it is not a 0, number 0, okay? And negative exponents means it's a fraction, or it's closely related to decimals, numbers with decimals. Obviously, fractions are decimals. Example 1. 7 raised to the 0 power. Okay, so how do we get there? We already know that when we have a number, let's say 7, and when it doesn't have any exponent, we know that it's exponent of 1. And then if we divide by 7, it will be exponent of 1. What is 7 divided by 7? We know it will equal 1. And if we follow the exponent rule, we know we have to subtract the exponents, right? And that will equal 7 raised to the 0 power. It's that simple, okay? It's that simple. Let's go ahead and do a few examples. So let's say if I say a raised to the 0 power, even though we don't know what a is, we know for sure it's going to equal 1, right? And what if I say, here's the confusing part, 2a raised to the 0 power? Now here's the important part. When we talk about the exponents that are next to a number or a variable, that's where they belong. So these two are separate. So if you were thinking, right, this equals 1, there could be an error, because a raised to the 0 power is 1, but 2 is raised to the first power, so that will be 2 times 1, and that will equal 2. That's a confusing one. It's a tricky one, so make sure you know that part. So 5 raised to the 0 power, you guessed it, 1. X raised to the 0 power, 1. 5x raised to the 0 power will be 5, okay? Because it's 5 times 1. All right. Now that we understand the 0 power and where it comes from, let's go ahead and understand what is an exponent with a negative power. Okay. A raised to the negative n power. It says that the rule is it's 1 over an, but how do we get there? So let's start with 7 that was raised to the 0 power equals 1. So if I go ahead and from here go down to, well, we start 7 raised to the first power equals 7, right? And then go down to, like let's do division, right? So if we're dividing, then we're going to go backwards to -1. So if 7 raised to the 0 power is 1, that means 7 raised with a -1 power, it'll be 1 over 7. Okay, and then if we go ahead and do 7 raised to the -2 power, it will be 1 over 7 to the 2nd power. Okay, that's where it's coming from. Okay, so one thing that students do most often, they rewrite this as 1 raised to the 7th power, and then they write -2. Well, we already simplified, right, the negative exponent, rewriting it as a fraction. So when you're doing that, you're writing fraction of a fraction. Here, I'm going to expand this for you so you can understand that is incorrect, right? It's not going to happen. So if I say 1 divide 7 raised to the -2 power, this means 1 divide by 1 divide by 7 to the 2nd power. I can rewrite it so you can understand it better. And then in division, we do keep it, change it, and flip it. And you can see that will be 7 to the 2nd power. So this is not the same as 7 raised to the -2 power. So make sure you don't make that error. This part was a bit confusing. Don't worry about it. Just as long as you remember that you're not going to write -2 when you're simplifying, you're writing 2, not -2, you'll be fine. Let's go ahead and do another example. Take this down. Okay, our second example here, it says x has a -3rd power raised to the -3rd power. We already discussed that it's 1 over x to the 3rd power, not -3rd power. Okay, and then I'm going to do one more with y raised to the -2 power. It will be 1 over y and 2, not -2. Similarly, when we have 1 over m raised to the 3rd power, we can rewrite it as a negative exponent by m -3 power, and n, right, raised to the 6th power means that is n raised to the -6th power. So we can go back and forth if you want to. So now let's pay attention to this one. This is a tricky one, and I want you to know because you will come across a lot often. So 2 raised to the 5th power divided by 2 raised to the 7th power. We know from our division rule that we're going to subtract the exponents. 2 raised to the 5th power minus 7. This will equal 2 raised to the -2 power. But again, our rule is we're not going to leave it as a negative exponent, and we know negative exponents are fractions. I'm going to rewrite it as 1 over 2 raised to the 2nd power. You can also evaluate this and write 1 over 2 times 2 is 4. Okay, that was a tricky one, and make sure you pay attention to that and make sure you finish it with a positive exponent, and if it's a number, you can evaluate if it's not a big number. Here's one example just for you. Go ahead and try it. Maybe I should include 1 or 2. All right, let's go ahead and write a raised to the 2nd power divided by a raised to the 5th power. What does that equal? And 6 raised to the -2 power. What does that equal? Pause the video and try on your own. Okay, let's go ahead and do this again. We know the division rule is that we will be subtracting the exponents. So a raised to the 2nd power minus 5 will equal a raised to the -3rd power. And this will equal 1 over a to the third power. And the second one, we will write 1 over 6 raised to the second power. Or we can write 1 over, what is 6 times 6? 36. Extra examples, multiplication and division of monomials. What does monomial mean? It means mono, one single algebraic term, which is like 2x raised to the third power. All right, so let's go ahead and start our first example. As we can see here, this is a multiplication. Just because there's no multiplication sign in the middle, it doesn't mean it's not, because we do have parentheses. Let's go ahead and find the rule. It says multiplying monomials, same base rule applies, add the exponents. So we do have the constant in here, the 5 and 2. What I usually do here is I organize the information that I have. I know this is multiplication, so if I move things around, it will not change the answer. And so that's what I'm going to do. First, I'm going to bring the 2 and 5 together and again follow the same base rule and bring the bases, same bases together, which in this case are the x's. All right, 2 times 5 is 10. And then I'm going to go ahead and it says add the exponents since it is multiplication. So there's 3 x's plus another 4 x's. And this will equal 10x, which I don't need to write the multiplication sign in there. We don't know. This is mono, single term, monomial, raised to the 7th power. Let's check our work. Yep, there's 3 x's plus 4 equals 7. All right, so let's go ahead and do the second example. This seems a bit more complicated, but it's not, again, because we will achieve the same goal by separating and identifying what is happening here, right? So again, we're going to separate 3 times 4, and then same thing, we're going to bring the same bases together. Remember that when a doesn't have exponent, it's exponent of 1 raised to the first power. And then let's go ahead and say b raised to the first power and times b to the third power. 3 times 4 is 12. And then we're going to go ahead and add the exponents. 1 plus 3. Okay, 12. And this will equal 12 a to the third power, 2 plus 1 is 3, and then b to the fourth power. Again, this looks like complicated multiplication and division of monomials. We're dividing the monomial, same base rule applies, and subtracting the exponents. Okay, let's see if we can do this. All right, third example. So 12x raised to the 5th power divide 3x to the second power. Again, I'm going to come back to how do we organize the information? How do we separate things and then put them back together? So let's go ahead and do that. I'm going to say 12 divide by 3 and then same base rule times x raised to the 5th power and then x raised to the second power. I'm not doing anything different. 12x to the 5th power means 12 times x to the 5th power, and same goes for 3x to the second power. It's 3 times. So I'm just going to put that times in the middle. It first says divide monomials. Okay, we're dividing 12 divided by 3 equals 4. And then we're going to subtract the exponents. I'm going to show that. And here we are, 4x to the third power. See how when we separate, everything becomes easy. Okay, let's go ahead and do the fourth. 15a to the 4th power, b to the 3rd power, divide 5a to the 2nd power, and b. Again, I'm going to separate everything just to see what I'm dealing with. Same bases together, a's with a's, and then b's with b's. Okay, once I do that, I can actually clearly see what's happening here. 15 divided by 5 equals 3. Then we're going to go ahead and subtract the exponents. Remember, there's 1 in here, and that will equal 3a to the second power, and then b to the second power. Okay, here's another one that might be not hard, but confusing. Again, we're going to work on our knowledge about the rules, right? And we're going to apply the same rules. Look at this one. It's very interesting. It's a lot of fun once you understand it. So the fifth example has powers of powers. So we're going to evaluate first to understand what do we see here, and then instead of writing x for multiplication, I want to write like that, so I won't confuse with the other x. Okay, let's start with order of operation. We're going to do the exponents first. Now, if there was the same base inside the parentheses here, I would have started with inside the parentheses, but they don't have the same base. So we're going to raise everything to the second power first. So x to the second power raised to the second power, and then y to the third power is raised to the second power. And then I'm going to rewrite everything else the same just to have it. Okay, so let's go ahead and multiply the exponents. I'm going to show you the multiplication, but you don't really necessarily need to do this step. But once you're learning, the time that you're learning, you can do it. All right, here we are. So x to the fourth power, right, times y to the sixth power times x to the third power times y. So now let's get the same terms together, same bases together. X to the fourth power times x with the third power times y to the sixth power, moving the y to the other side. Don't forget it's 1 in here. Okay, what is the rule for multiplication with the same base? We're going to add the exponents. This means here x to the fourth power plus 3 and y to the sixth power plus 1. This will equal x to the seventh power and times y to the seventh power. You can rewrite it just like that. That's it. Again, we leaned on how to organize the information and then following the rules of powers. Okay, I'm going to rewrite the last example. In fact, pause the video and try it on your own. See if you can apply the same rules. Again, organize the information and apply the power rules. Okay, example 6. A raised to the fourth power Okay, pause the video here and try on your own. So again, I'm going to go ahead and multiply power of power rule, following power of power rule. Leaving the bottom part, the denominator alone. And then once I did that, so that will be a raised to the 4 times 3 is 12, and then b 2 times 3 is 6. A raised to the fifth power and b. Don't forget to write 1 so you can clearly see what you're doing. All right, if we separate a's, that means 12 minus 5. And then again, we're following the division rule by subtracting. Six minus 1, and this will be a raised to the 7th power, b raised to the 5th power. That's it. All right, one last thing to note, negative numbers with exponents, there's a specific rule that follows this. If the negative sign is inside the parentheses, the entire number is being raised to the power. That means the base is a negative number. So I'm going to show you here when we have -3 and is raised to the second power and the negative is inside the parentheses, this means that we are multiplying -3 is our base twice. And so the answer will be 9. Here's another one. When we have -3 and negative is not inside the parentheses, the answer will be -3. So the base is not -3 times 3. So the answer will be -9. Okay, so those two are two different things. As you can see, we're getting two different answers. So make sure when you are writing a negative number, and if you know it's a negative base, you need to put it inside the parentheses in order to raise to a power. Okay, one other thing that I would like to tell you is, what if -3 is raised to the third power? What does that mean? That means, again, the base is -3 times -3 and times -3. And what would that be? Now think about it. Will we end up with a negative number or a positive number? So if you said negative number, you're absolutely correct, because -3 times 3 equals 9. And then we're going to bring down 9 times -3 will equal -27. So remember, if your exponent is an odd number, then we'll end up with a negative number. If your exponent is a even number, then we end up with a positive answer. So let's try one more. Now we're taking a log and we can clearly see that -2 is inside the parentheses, so the entire thing will be raised to the third power, which means our base is -2. Let's go ahead and do that. Before I write the answer down, try and guess, are we going to end up with a negative number as an answer or a positive number? So -2 times 2 equals 4, and 4 times -2 will equal 8, and it will be a negative number. Okay, so I'm going to erase this and give you one problem. See if you can, one or two, so you can do this. Okay. All right, so let's go ahead and try -4 raised to the second power and -4 raised to the second power, -5 raised to third power. Okay, so go ahead and do that. Pause the video and try your best. Okay, so let's go ahead and try this. -4, this means if it's inside the parentheses, the entire thing is raised to the entire number. The base is raised to the power of 2, which will equal 16, and it will be +16 because our exponent is an even number. So -4 raised to the second power means -4 times 4, which will equal -16. And then last but not least, -5 is inside the parentheses. That means the entire number is raised to the power of 3. And -5 times -5 times -5, and which will equal -5 times -5 will equal 25. 125 times -5 will equal 125. And of course, you guessed it, it will be a negative number. All right, so let's summarize what we have learned. So for multiplication, meaning if a raised to the m power is multiplied a raised to the n power, we are adding the exponents. For division, what are we doing? We are subtracting. Okay, so for power of power, we are multiplying the exponents. And for negative exponents, it means it's a fraction. So let's go ahead and write the fraction. So a raised to the negative m power means it's 1 over a to the m. And when we have 1 over a raised to the negative m, that will equal just a raised to the m power, exact opposite. 0 exponents are any number that's raised to 0 exponents equals 1. And negative numbers should be inside the parentheses if we have the base as a negative number. Let's go ahead and write negative a raised to the n power. And if we have a negative number as a base, that means we're raising the entire thing, and it has to be inside the parentheses. So -2, this will mean -2 times -2, the answer will be 4. And if we do not include the parentheses, that means the base is not -2. We put the negative at the front. It will equal -4. Great job, everyone. I'm so glad you made it to the end of this video and learned everything you need to know about exponents. These skills are foundation what's coming next, scientific notations. In our next video, you will use everything you just learned about exponents and understand how scientists and mathematicians write really big or really small numbers using scientific notations in a quick and powerful way. If you like this video, please like and subscribe to Teaching Math, and remember, learning math takes patience, practice, and persistence. See you next time.